Following is an excerpt taken from the first of 3 sessions that make up the 7-hour-long Module 5 training course on process piping design. This brief excerpt discusses the manufacture of steel and related material test reports. When discussing metallic materials, you will often hear the term heat, or heat of material, or melt. In the pre-production of steel, iron ore is melted in a blast furnace and mixed with coke, the carbon residue of coal. The molten iron is then poured into ingots referred to as pig iron. These are simply lumps of iron that vary in size and form. They are used as feedstock when making steel. It is the principal raw material in making steel and is stockpiled for use as needed. The pig iron is mixed with varying quantities of scrap metal and alloys to manufacture different types of steel. The blast furnace in which the molten iron is made is tapped and poured from the furnace, a basic oxygen furnace or electric arc furnace, into ladles, which you see here, to be transported around the steel mill to make various steels. As noted, there is about 120 tons of molten steel in this ladle, which is considered a heat of material. The various processes this ladle of steel will go through, in addition to the various alloying constituents added to it, will create a one-of-a-kind chemical fingerprint, a fingerprint specific to the heat number assigned to it. Here you see scrap being added to a heat of material along with a cocktail of alloying material in meeting the recipe for a specific type and grade of steel. The finished steel is then turned into raw product forms such as billets and slabs. Manufacturers of pipe and tubing then order either billets that they use to form into seamless pipe and tubing, or they ordered rolled sheets from the slabs which they cut into scalp, which are thinner strips of rolled sheet to form welded pipe or tubing. This is a test report, better known as an MTR, material test report. The MTR contains information about the chemical and physical properties of each batch or heat of material and is generated by the mill. While creation of the information on the MTR is a requirement of the mill, this information is only passed along the supply chain at the request of the purchaser. Product manufacturers, such as a tubing manufacturer in this case, will in many cases transpose the data from the mill's test report onto their own MTR form, which is what we have here. The properties, both chemical and physical, have to be within the ranges, minimums and maximums specified within the chemical recipes of ASTM and other accredited standards organizations. The MTR is a means of verifying and noting that fact. The MTR form can be broken down into 3 main segments of information. The first being the general order information. The second being the chemical properties of the metal. And the third being the mechanical properties of the metal. As you can see here, along the top portion of the general information is the order and shipping information. Below that is a description of the material. Along the left side it indicates the size and type of material, heat treatment if any, and the addition of the ASME and ASTM standards it complies with. The prefix SA indicates that this is an ASTM standard that has been proven and accepted and maybe even modified by ASME. The information on the right is the manufacturer's ship-to address, product number, quantity, and number of pieces. It also indicates the manufacturing process used at the mill in making the steel. In this case, it was the electric arc melt, EAM, method of creating the molten metal, and the argon oxygen decarburization, AOD method used in refining stainless steels and other alloys. Stainless steels and other molten alloys typically go through a 3-step refining process which includes AOD, what is referred to as reduction and desulfurization. These final 3 steps in the process help control the final chemistry of the metal through additives and temperature control. In looking at the chemical analysis data from the original heat of material, the chemistry has to comply with both SA312 requirements ASME and the A312 requirements ASTM as indicated previously. If not, both standards could not be listed. E1476 is an array of test protocols. This part of the MTR provides mechanical test results, and like the chemistry, it too has two sets of results. The added ASTM A262 testing at the bottom is for standard practices for detecting susceptibility to intergranular attack in austenitic stainless steels. This marks the end of this excerpt. For more information on the complete course, please contact us at courses@wmhuittco.com. In the subject line, enter Request Info on the Module 5 Piping Design course. Thanks for watching.